So hello everyone. Today we shall move to the next exercise, exercise 4.2, chapter 4. So the first question is that using the property of determinant and without expanding in exercise 1 to 5, means question number from 1 to 5, prove that these determinant give the result 0. And we have to find 0, we have to show the result is 0 without expanding, but using only the determinant properties. As I gave you 8 properties in the last class, using any of the property which is most suitable in this exercise, we have to implement it and find the value as 0. What can we do is, so that is why I told you many times to go and revise those properties, and now it will really help you to solve this exercise very nicely. So let me help you what can be done and what property will we use here to give the result 0. So my dear, you can see the first row is x a x plus a, y b y plus b, z c and z plus c. How can you make 0? As we got one property 3 or 4 like that, in that property we have learned that if any two row or if any two columns are identical, means same, if two row or two columns are identical, then the result of the determinant gives you 0. So here we can make it 0. Okay, if I add first column with second column, x plus a, we can obtain x plus a. You can see y plus b, we can obtain z plus c. So by applying one property, we can make the two column equal, and when the two column is equal, we can clearly say that the value or the result of that determinant will give you 0. So very nice. So let us apply the property here. That applying, let me write what property we are going to use here. Applying column 1 is changed to column 1 plus column 2. This property we are going to change. As this property is only implemented in column 1, so there will be no change in column 2 and column 3. So let us represent the determinant as delta. Delta is equal to column 1 plus column 2, x plus a, y plus b, z plus c. As there is no change, there is no any properties used in column 2 and column 3, it will be remaining as same it is how it is in the above case. A, B, C and x plus a, y plus b and z plus c. Now what can you say that we have seen that first column and third column is completely same, are identical, and hence we can say that the value is equal to 0. How? You have write the reason. Here you write since the two columns are identical, so determinant is equal to 0. Therefore I can say that x plus a, x plus b, x plus c, a b c, x plus a, x plus b, x plus c is equal to 0. That is proved. I hope you can catch what I mean to say here. So you'll understand better if we go on solving few more questions from the exercise. It will help you really. Thank you. So here goes our next question 2. So this is the given determinant to us and we have to prove the result is 0. Okay, so it is an important question. It came many times in CBSE board. So now we have to analyze what can we do, what can be done in these questions. That's a very strong point. Now you can see you can try to observe the similarity among them and then apply your common sense. What can be done here? So a minus b, b minus c, c minus a, b minus c, c minus a minus b. Are C minus A minus B, B minus A. These are the three columns. But one common thing that we can observe from here, we can see that the same type of element is repeated. Like here, A minus B, here also A minus is present, here also A minus is present in this first column. The second element is what? B minus C. B minus C is here, B minus C is here also, B minus C is here also. Third thing what we observe, that here is C minus A, here also C minus A, here is C minus A. That means whatever the element present in the first column, the same elements are present in column 2 and column 3. This is the similarity that we have observed, that we have found here. Now what can we do is that, let us add all the element of the row in a particular column. Clear? So what I'm going to add all these column. Okay? That means row 1, row 2, row 3 will be adding. So let us implement, applying on R1. I'm changing in R1. R1 is changed into R1 plus R2 plus R3. Let us do now. So when you change it, what can you see? A minus B plus R2 is B minus C plus R3 is C minus A. Same goes for his also. B minus C plus C minus A plus A minus B. Same goes for this one, this row column also. C minus A plus C minus A plus A minus B plus B minus C. That's all. Now there is no change in the column 2 and column 3. Let us write same as it is. B minus C, C minus A, C minus A and A minus B. Here also A minus B, B minus C. Now let us try to open the bracket. Let's open the bracket here. A minus B plus B minus C plus C minus A. And here is what? B minus C, C minus A. Let's move here, same thing. B minus C plus C minus A plus A minus B. Here is C minus A minus B. Same thing. C minus A plus A minus B plus B minus C. A minus B, B minus C. Clear? Is that clear, my dear? I hope so. Now we can apply one thing. You can see we can cancel out. If you can observe nicely, you can see we can cancel this A plus A minus A plus B minus B plus C minus C. What is left? 0 is left. In this case, what is left? 0 is left. Same thing, B minus B plus C plus A minus A. What is left? 0 is left. C, C, B, B, C, C cut. What is left? 0 is left. Oh my God. So let us proceed to the next part now. So what we have seen, that delta from this point, we are going to this point now. Delta is equal to what? 0, 0, 0. B minus C, B minus C, C minus A, C minus A. And here is what? C minus A, C minus A, A minus B, A minus B. And here is A minus B, A minus B, B minus C, B minus C. So we got one more property in determinant, that that property says that if any of the row, complete row, or any of the column is 0, then the result of that whole determinant will give you 0. This is the property that we have got, right? Now let us write that property, what we will write here. I hope that's clear. So all the elements of R1 are 0. So we can write that all the all the elements of R1 is 0, so the determinant is equal to 0. Clear, I hope so. Therefore what we can say, y is equal to 0. So easily we have proved it. Now let us move to the third part. I hope that thinking ability is growing within you. That is why I told to revise those properties. So after finishing this part, try to go against the properties. This is really important part. Okay, so my dear, let us proceed to the next part now. So here goes our next questions. Yes, nice question. We can see question is given as these elements are there in the determinant: 2, 7, 65, 3, 8, 75, 5, 9, 86. Now we have to prove it 0. Now what can be done now? A nice question now. So how to do this one, and let us apply some common sense. What similarity we can see? So we can make a 0 when we can make 2 row or 2 column as identical. When any two column or any 2 rows are equal, exactly same, then we can say that the result will give 0. So how can you obtain 2 row or 2 column identical? What difference you can see? Can you break any change here? That's the question. Now can you bring here 65 or here? Let's see. If I multiply 7 9 ja, how much? 7 9 ja 63. Oh my god. If you multiply it 7 with 9, what we can see? 7 9 ja 63, but we are not getting 65. Can you see? We are not getting 65. We are just lacking with 2 numbers. 2. If I add this 2, then we can obtain 65. You can see the result. If I multiply 7 9 ja, what we are going to obtain? We are going to obtain 63, not 65. So to obtain 65, if we can add these two, then we can easily obtain 65. You can see the common sense. Similarly here, if I multiply 8 with 9, so 8 9 how much? 8 9 is 72. Oh my god, 72. When 72 is again added with 3, wow. So we are going to obtain 75. Yes. Now again, if I multiply 9 9 how much? 81. 81. When 81 is added with 5, you can see you can obtain 86. Can you see the similarity? Okay, this is a pattern. We have to understand pattern. What can we do? Okay, it's a very simple logic that we have to apply. This is why common sense is really needed here, and the power of properties. That's all. So let us implement here very nicely. So let us bring a change. Let us try to bring a change here. That I'm bringing a change in column 2. Applying right here. Applying what property we are going to apply? Applying column 2. Column 2 is changed as column 2 into 9 plus column 1. Wow, this is a nice question. This is the property that we are going to apply here. I think this property belong to property 7. I have written mostly used that property we are going to use here. You can turn on the page and see the property that I mentioned. That property number 7. That column 2, I'm bringing change in column 2. Column 2 is changed to 9 times of column 2 plus column 1. So let us bring the change now. Look here. As there is no change in column 1, write it exactly 2, 3, 5. No change in column 3, 65, 75 and 86. You can see column 2, 7 9 ja 63 plus 2, 65. Oh wow. So again here 8 9 ja 72 plus 3 how much? This is 75. Again 9 9 81 plus 5 85. So you can see the column 2 and column 3 are exactly identical. So you can say here column 2 and column 3 are exactly identical or same. So I can say that here use a delta. So we can say that 2 3 5 65 75 85, that is your 65 75 85 give you 0. Proved. I hope you're enjoying it. Very interesting, right? So let us go to the next one. See this same type of questions. just apply the same common sense. Just try to observe the pattern that is belonging to these questions, and when you can catch the patterns, you can easily deal with the questions. That's the thing. I hope you can understand what I'm saying here. Good. So here is another nice question number 4 of the exercise 4.2. So the question is given as follows: 1 BC 111 BC CA AB A plus B B plus C A plus B. So firstly, let us try to expand it and see the what similarity and what pattern we can observe, and after observing the proper pattern, we can apply the properties here. So look here, A111 BC CA AB AB plus AC BC plus BA, or you can write AB also, no problem, and CA plus CB. That's all. So we can see this one. So what similarity we can see that, my dear? Look here. Here is AB AC. Here is BC. Here is BA. Means this one is equal. Here is CA and CB. But we can see AB. Here BC is missing. You can see when we add this one here, what we get? AB BC CA. Here is AB BC CA is missing. Let me add here this one. So what we can AB BC CA we will be getting here. Same thing if we add here AB, because AB is missing here. AB BC BC CA. Oh my God, fantastic! So what we are going to do is that let us add the element of column 2 in column 3. So we will get the same result. So what we are going to do is that applying column 3. Column 3 is changed to column 3 plus column 2. Column 3 plus column 2. So here 1 1 1. There is no change in column 2, right? BC CA AB, and here is AB BC CA. Wow, same thing, AB BC CA AB BC CA. Here also AB BC CA. So you can see these three elements of the column 3 are same. So what happen when anything is same, we can take it as a common. So let me take it common and bring it outside. Clear? Let me take it as a common and bring it outside of the determinant. Okay, I told you in the previous class, for example, there was an example now. Suppose KA, KB, KC, and here is P, Q, R, X, Y, Z. If you can see such thing, we can take the K outside, because K is common to a particular column here. So if I take K outside, so it will become A, B, C, P, Q, R, X, Y, Z. This is the property that we get. So that property we are going to use in this case and obtain the result. Let's see what we are going to obtain. Let me drop this part. Okay. Fantastic. So now that delta is equal to, we are bringing outside AB plus BC plus CA. What we got? 1 1 1 BC CAB BC CA AB. So if you take whole outside, what is common here? 1 1 1. Wow, such a good result we obtain here. Now we can see the first column and third column is identical, and we already know that when any two columns are identical or any two rows are also identical or same, we can say the result of that determinant will be give 0. So here we can write that here column 1 and column 2 are same you write, or identical here wish. So we can write that, so delta is equal to 0. Delta is equal to 0, or this is equal to 0. So delta is equal to 0. That's a simple thing that we have observed. Clear, my dear? So if delta equal to 0, then you can say that leave it, that's all, finish. Answer is finish at all here. Okay. So if this is 0, this also are 0. So if C1 and C2 are same, we can say that 1 1 1 B C C A B 1 1 1 is equal to 0. When this is 0, 0 into anything is what? 0 into anything is 0 only. Therefore delta equal to AB plus BC plus CA into 0. Into 0 is what? So therefore delta is also 0. Means this is the form here. So now let us move to the next one, fifth one. Very nice, good. So here's the next questions. Nice question. Look here, question number 5. This is the first determinant. We have to prove it twice of this determinant. BC Q plus QR plus YZ CA plus C plus A Q plus P Z plus X A plus B P plus Q X plus Y is equal to twice of A B C P Q R X Y Z. How to do this one? So as you can see the pattern here, it is like question number 2. Here B C C A B is there. That means A B. You can say it's the same thing, right? 2 to A is there, 2 to B is there, 2 to C are there. So let us add all the row here, first row, second row, third row, and same similarity you can see on 3 of the case. So let us apply the property. We have to prove the left hand side is equal to right hand side. So we have to use the property, then only we can prove it to the right hand side, right? So left hand side, applying what property? R1 is changed to R1 plus R2 plus R3. This is the change that we are bringing here. So let us bring the change. So therefore delta is equal to B plus C plus C plus A plus A plus B. This is the first change. I am adding all the element here. Same thing is going for column 2, that Q plus R plus P plus P plus Q. Next thing is for this one, Y plus Z plus X plus Y. Wow, nice. And keep it same. C plus A and A plus B, R plus P plus Q, Z plus X plus Y. Now let's see here, delta is equal to, you can see B, 2B are there, so you can write twice B, 2B, 2C, 2A. Wow, nice. 2B, 2C, 2A. So we can write double of A plus B plus C. So we can take 2 is common, because we come to see that BB, what is the answer? 2B. CC, so A, 2A, BB, 2B, CC, 2C. So what we can do is that we can take 2 common. When 2 is taken as common, so what is left? A plus B plus C. Same thing goes for this also. 2P, 2Q, 2R. So let me write 2 common. 2P plus Q plus R. Same thing goes for this also. 2Y, 2X plus Y plus Z. The 2 is taken common. 2X plus Y plus Z. That's all. So let us write as remaining factor. C plus A plus B. Here is also R plus P plus Q, and here is Z plus X plus Y. Clear? So now next step will be, we will take the common, because you can see this 2 is present in all the first row. So when 2 is taken common, we can obtain this 2 here. Let us take out 2 as common now outside. So let me use another page here, means another board, to clearly define it. So let us do it now, solve it nicely. Now 2 is taken as common now. Let us write. Therefore, delta is equal to twice of A plus B plus C, A, B, C, P, Q, R, X, Y, Z, X, Y, Z, C plus A plus B, R plus P plus q, x plus z, x plus y. Can you see that? Can you see? Good. Now what can I do to obtain a, b, c here? That's our main concept. That's the main our concept what we are going to use here. So let us try to bring some changes. Let's try to bring some changes over here. So how can we bring that changes? That's the very nice questions now. Wow, great. So you can see one thing. Here is C and here is A. I need here B. I need here B. How can you bring this B here? Very nice. Because already in the answer part, what is given? In the answer part, that is given 2A, B, C, P, Q, R, X, Y, Z. So there's a common sense now we have to apply. So how can you obtain A, B, and C here? How can you obtain B? There is no B. There is no any B in this column 2, row 2. How can I bring B? This is the question. Now, but B is here. But B is here. So what we are going to do is that let us subtract the value of row 2 with row 1. So we can see C and A will cancel out. Only B, C will left out. Right? So let us apply here. Let us see what can I do here. Very nice. So applying R2 change to R2 minus R1. So okay, fine, great. So delta is equal to twice of A, B, C, P plus Q plus R, X plus Y plus Z. Now C plus A minus A plus B plus C. Okay, same thing goes for here also. R plus P minus P plus Q plus R. Wow. And third is what? X plus Y plus Z. What is here? Z plus X minus X plus Y plus Z. That's the point. Wow, great. And from here, if we cancel C, B, A, B will left, means minus B will left. Okay, fine. So minus B will left, minus Q will left from here, and minus Y will left here from Borea. But now question is that how can you obtain here C? Because I need C in place of A plus B. C. How can you bring C? Same we are going to apply. If we subtract the value of C, row 3 with row 1. Now we can see A, B will cancel out, C will left out, right? So let us apply. Also we can write and you write here and you write column 3 means row 3 is changed to row 3 minus row 1. In the same property we are going to use here to reduce our steps and our hard effort. So what we are going to do is that now let us see here A plus B minus first row A plus B plus C. Means same line, the same step we are going to apply as we applied in row 2, same step we are going to apply for row 3 here. Try to understand, because we are going to obtain here C. How can you obtain? There is no any other steps, there is no any alternative way to obtain here C. But we can say that when you substitute the value of row 3 with row 1, you can say A, B will cancel out easily, C will left, means minus C will left. So when minus is left, we can take minus common. There is no any problem with that. So let us go working with this case now. Look here, same thing is going for here. P plus Q minus P plus Q plus R. Same thing for here also. X plus Y minus what? X plus Y plus Z. This is the point. So okay, delta is equal to twice of A plus B plus C. Okay, A plus B plus C, and let us see the value below case. C plus A, let us try to eliminate the bracket here. A minus B and minus C. Okay, great. Same thing here also. A plus B minus A minus B minus C. Same thing goes here. P plus Q plus R. Here is R plus P minus Q minus R. Here is p plus q minus p minus q minus r. Same thing is here also. X plus y plus z. Z plus x minus y minus z minus z. Here is x plus y minus x minus y minus z. So whatever the cancelling part, cancel it out. A plus a minus a cut, b is not b cannot be cut here, b will be there, minus c plus c. Same thing here is a cut, b cut, c is left. Wow, great. Same thing is here, r plus r minus r, plus p minus p cut, q is left. Same thing as plus p minus p, plus q minus q, r is left. Same thing as plus z minus z, plus x minus x is cut, y is left, and x y is cut, minus z is left. So what is the left out quantities? Write down it nicely. So delta is equal to twice of a plus b plus c. Here is minus b minus c. Minus b minus c is left. Same thing is here, p plus q plus r. What is minus what? Minus q and minus r is left. Same thing is here, x plus y plus z. X plus y plus z. What is left? Minus y minus z. Wow, great. So almost we are close to the answer. Now see, you can do one more action here. Now I need a here. I need a here. A. So to bring here a, I have to eliminate the value of b and c. Already you can see minus b here, minus c here. So if we try to add the column 1 with column 2 and column 3, when column 2 is added with this, so b cancel. When column 3 is added, c is cancelled. You can see same thing is here. You can see when column root 2 is added to column 1, q cancel, and column 3 with the help of column 3, r will cancel out. Same thing, y will cancel out, z will cancel out. Only what will left? Only there will be, what to say, this will left, x will left. So let us move to the next steps. So I'm just using in here. Okay, I'm just using this part. Can you see, my dear? So I'm using this part for your convenience. Yeah, you can see I have used a margin here. So let me put another case. So now we are going to applying R1 is changed to R1 plus R2 plus R3. Clear? So what we are going to do? Delta is equal to twice of a plus b plus c. What is plus R1? Plus R1 means plus R1. R1 is what? B minus b plus R2 minus c. You got it? Same thing is I'm going for that also. The class is very limited. Let me wrap this one. Okay, 1 minute. Same thing here. Let us bring the change here also. P plus q plus r plus minus what? Minus q plus minus r. Wow, that is nice, right? Now same thing is bringing change here also. X plus y plus z, x plus y plus z minus y or plus minus y plus minus z. You can see. Great. So what is the remaining part? Minus b minus c minus q minus r minus y minus z. So what we can see, plus b minus b plus c minus c cancel, plus q minus q plus r minus r cancel, plus y minus y plus z minus z is cancel. So what is left here? Delta is equal to twice of a minus b minus c, p minus q minus r, and here is x minus y minus z. Almost we are close to the answer now. Now we are having problem with this minus because we have to eliminate this minus. So what we can take is that we can take this minus common from here. We can take minus common from here, obviously, because this minus is present whole through the second row. Okay, if anything is common, we can take it common, no problem. There is, okay. So and there is also minus common. So there's 2 minus common, we can take it out. So what we can do, delta is equal to twice of minus minus and again minus. We are taking 2 minus common. So what is left? A P X minus taken from minus minus minus. So what is that? P Q Y C R Z is left. So this minus minus become plus. This minus minus gives you the result plus. So when it is plus, there is no problem. Answer is your complete. So answer is your delta is equal to twice of y is equal to your right hand side, and hence that is proved. I hope you can understand, my dear. So interesting, right? So interesting. This is the second part. Very interesting part. So try to understand this once again. It will really help you to solve the upcoming questions also.